right, so now we're going to be talking about flow diagrams and tables of values because they are different ways for us to describe our function relationships. All right, so we've been speaking in the previous lessons about the relationships between input and output numbers, and how one of the ways that we can represent this is by using a flow chart, which is the diagram that is here on the left. And I'm sure you've seen those at school. You've certainly seen them at Watobe. They give us a set of input numbers and a rule, and they expect us to calculate output numbers. But they could also give us the output numbers and expect us to calculate the input numbers. And another thing that they could do, and that's something that I want to do with you today as well, is that they could give us the inputs and the outputs and expect us to complete the rule. So we would need to be able to do all of those things in order to be able to complete a flow diagram. All right, and then the other thing that we could do is that we could choose to represent this information in a table. All right, so the table that's there on the screen at the moment shows what goes in and it shows what goes out, and you've seen tables like that before. We're going to talk a little bit more about that today as well. Okay, so flow diagrams show us two kinds of information, as do tables. It shows what calculations are done to produce the output number, and it also shows which output number is connected to which input number. All right, so if we have a look at a situation like this one over here, we can see what it is that I'm talking about. Here's our rule in the middle. Our rule is telling us to, first of all, multiply by 2 and then add 3. The first couple of questions are a little bit more challenging. I don't know if you guys remember doing this from the last time, but it's just thought we would start here with something that is familiar to us. All right, so the very first question gives us an output. All right, if we have a look over here, what I'm highlighting in blue, in turquoise, that is an output. What they're expecting us to do is work backwards to the corresponding input, which should be over here. All right, Lucy, what's your question?
Ma'am, I just wanted to know if we are going to be doing new sums today.
Yes, absolutely.
Okay.
Absolutely. Then. I'm just doing a this is just one thing that I'm just showing you from what we've done before, just so that we're all on the same page. Okay.
Okay.
Right, but all of the work that's coming up here is new stuff. Okay, it is every single lesson. Every lesson is new material. Okay, Takalani, what's your question?
Ma'am, I didn't want to ask a question, ma'am. I wanted to answer.
Oh, okay. All right. So did you want to tell me what I should be writing on the left as my input if my output is 3?
Ma'am?
Did you want to tell me what I was supposed to write over here?
Yes, ma'am.
Okay. All right. So what should be written there, Takalani?
Ma'am, it's going to be 0.
It's going to be 0. It certainly is. Okay, because we would have to work backwards. So we would start with our output, we would do the opposite operation, which is to take away 3, we would end up with 0. And then if we take 0 and we divide it by 2, we would end up with 0. So quite right, that is correct. Okay, let's see whose hand is also up. Okay, Rolivua, can you tell me what the next input is going to be when 5 is the output, please, Rolivua?
1.
It's going to be 1. Okay, and how did you work that out?
You go 5 minus 3 divided by 2.
Lovely, perfect, well done. Okay, really, really nice. And now I'm going to ask Jaden, when 5 goes in, what number comes out, Jaden? Okay, but you put your hand up, Jaden, so I presume that you knew what we were doing here. Right, so we're looking now at this input here that I've just colored in turquoise. So 5 goes in, it's times by 2, we add 3, what comes out, Jaden? It's okay.
13.
What comes out, Jaden?
13.
13. Good job. Okay, lovely. 100%. Okay, very nice. Motsebang, you're next. 9 goes in. What number comes out?
You times 9 by 2, which will give 18, plus 3 will give you
Yes.
21. 21.
That's it, Motsebang. Well done. 100%. Okay, good job. All right, Tatelo, you next. When 11 goes in, what happens?
Hi, ma'am.
Hi, Tatelo.
Ma'am, so it's 11, right?
Mm-hmm.
It's 11 times 2, which is 22. Then you add 3, which is 25.
100%. That's great, Tatelo. Well done. Okay, so everybody is comfortable with how we do those. That's lovely. Okay, so now what I wanted us to have a look at is what would we do if we had to write the appropriate operator into the flow diagram. So in other words, what we've got are our inputs on the left. Okay, so I'm highlighting the inputs in turquoise. Okay, those are the inputs. And what we have are our outputs. I'm going to highlight those in pink on the right over here. So those are our outputs. How are we going to work out what the rule is? And I see Buhle's got his hand up next. Buhle, how are we going to work out what the rule is?
Ma'am, so basically I did what you do, what you do to get for numeric and geometric patterns. I see the relay how many like for 1 to 4, I know it's 4, so I got, and I calculated for the other answers and it gave me 4 also.
Absolutely. So when you say 4, what are you doing with the 4, Buhle? Adding 4, timesing by 4, dividing by 4?
You timesing 4.
Absolutely. All right. How are we going to write that as a rule? If we had to use X and Y, how would I write that as a rule? Do you know, Buhle?
I think X times 4 equals Y.
Absolutely. All right, very nice. Okay, so what they'll teach you when you go to high school next year, there's nothing wrong with what you've said, that's perfect, is they'll teach you to write the Y first. And then they'll teach you to write X times 4 as 4X. Has your teachers at school explained that to you, that it means exactly the same thing?
Yes, ma'am.
Okay, all right, that's fine. Okay, so I see somebody's got their hand up. Just hold on a moment, everybody. Just give me 1 second. 1 second, everyone. Okay. All right, let's continue. So now this is something that you guys are going to have to do a little bit on your own, all right? This is going to hopefully provide you with a bit of a challenge, especially if you're not allowed to use a calculator. What we're looking at here is the rule for converting temperature given in degrees Celsius to degrees Fahrenheit is given as multiply the degrees Celsius by 1,8 and then add 32. Okay, so what I'm going to do is I'm going to get you, don't worry about part A, all right? What I'm going to do is I want you guys to have a look at what is going in. So temperature in degrees Celsius is our input. Temperature in degrees Fahrenheit is our output. Okay, so what I want us to do is I can do the first one with you, for example. All right, and then you guys are going to try 5 and 20 on your own. You're going to try 32 on your own, and then we're going to see how smart you are if you can work backwards from 212. Okay, so what they've said to us is that we need to take degrees in Celsius. So in the first case, we're going to take 0 degrees and we're going to multiply that by 1,8. We are going to get 0 as our answer. All right, so if we multiply anything by 0, we always get 0, don't we? And then we're going to take our answer and we're going to add 32. So our first answer should be 32. And there it is. Okay, awesome stuff, right? Now, you guys are going to try 5 and 20. You're going to calculate the outputs. And then we're going to see how clever you are if you can work backwards and calculate the inputs. And then when you've finished, when you've done all 3 values, then you can say done in the chat. Okay.
Excuse me, ma'am.
Yes.
Ma'am, for the last one, ma'am, do we use inverse operation, ma'am?
You're going to have to use inverse operations. And even if you get it wrong, it doesn't matter. I'll go through it with you. I just wanted to give you something a little bit more challenging to do.
Yes, ma'am.
Okay. All right. So you're going to try those. And Kat and I are going to be quiet for a little bit. And when you're finished, you say done in the chat.
Ma'am,
Yes, Masi Zazi?
I just wanted to ask, are we going to use 1,8 with 5?
Absolutely. So you've got to, where I did 0 as an example with you, remember here, I took 0,
Yes.
I multiplied it by 1,8 and I got an answer. And then to my answer, I added 32. You've got to do the same thing with 5.
Okay, ma'am. Thank you.
Okay, no problem. Okay. Oh, it's okay, Cynthia. I'm sorry you don't understand. That's fine. Okay, so Cynthia, what I wanted you to do, right, was work out the appropriate output given the input. Okay, so I did it here with 0. What I was expecting you to do here was to do the same thing, but with 5. Okay, so it tells us what the rule is. It says multiply the degrees Celsius by 1,8 and then add 32. So here is the temperature in degrees Celsius. So you have to take 5 and you have to times it by 1,8. Right now, we've done a course on multiplying decimals before, and that's something in grade 7 that we should be able to do. Okay, we should be able to multiply 5 by 1,8 and work out what the answer is. So I didn't do the course on decimals, but in the past when I have taught this, what I've taught is that you've got to take 18, you drop out the decimal comma for now, times it by 5, and you're going to work out what the answer to that is. Okay, and so 5 times 8 is going to leave us with 40. 5 times 1 is 5, plus 9 is plus 4 is 9, so that gives us 9,0. Okay, so if we had 1 decimal place in the question, we've got 1 decimal place in the answer, and now we've got to take our answer of 9 and add 32 to it, and then we get 41. Okay, so that's what I was asking you to do. All right. Okay, so it wasn't supposed to be difficult. Let's see who's finished. How many people are done? Okay, so there's a few people that are done. Those people that are done, what you can do is you can also represent the information in the flow diagram while you're waiting. And then we'll call on people to give answers. Cool, all right. You can, Luam. I'm going to do it with you now, but give it a try while we're just waiting. Yes, absolutely, Brulela. Do be in the meantime. Cool, Lesejo. Okay, so hopefully Kat and I have given you guys enough time to be able to work out the remaining 2 answers, or sorry, remaining 3 answers. Let's go and see who's got their hands up, and we'll start at the top. Okay, so Amukalani, your hand is up first. Do you want to tell us what happens when 20 goes in? Or do you want to put your answer in the chat, Amukulani?
No, ma'am.
Okay.
I wanted to ask a question, ma'am.
Okay. Do you want to answer a question or did you want to ask a question?
I wanted to answer, ma'am.
Sure. So answer me the one where 20 goes in.
Ma'am, it was answered, ma'am.
No, the one where 20 goes in, not the one where 5 goes in.
Oh. Still calculating it.
Oh, okay.
I'm not sure about my answer.
Okay, even if you get it wrong, it doesn't matter. What did you get?
Ma'am, Let me calculate it again, ma'am.
Okay, that's fine. I'm going to ask someone else in the meantime, and then when you figure it out, you can put it into the chat, okay? All right, Jaden, what did you get? Your hand is up next. Okay, so Jaden didn't want to answer. Masizazi, your hand's up next. What did you get?
Yeah, I know this. It's like I can't calculate it.
You
I just
can't.
can't get it.
Oh,
Yes,
okay,
ma'am.
that's fine, not a problem. Okay, Ellie or Eli, I'm not sure if I pronounced your name correctly. You tell me what you think the answer is.
I'm not sure if it's 68, ma'am.
If it's 68, that's a very good answer. Can you tell me how did you get 68 as an answer? What did you do?
I multiplied 20 by 1,8 plus 32,
Lovely.
ma'am.
Absolutely. Okay, in fact, you can do that all in one step if you want to. Okay, so 20 times 1,8 plus 32 does indeed give you 68. That's good, Eli. Well done. Is that how I pronounce your name, Eli?
Yes, ma'am.
Okay, well done. That's great. Boutle, you're next. What happens when 32 goes in, Boutle?
Ma'am, the answer, wait, let me quickly mark. Okay, the answer is 89.6.
No, you're quite right. Did you think you'd done it wrong?
Yes, I thought I did it wrong.
No, you didn't do it wrong at all. So how did you get to that answer, Boutle? Explain to me what you did.
So, ma'am, I did 36 times 1.8, which gave me 64.8. Then I added 32, which gave me 89.6.
I think when you've multiplied 32 by 1,8, let's just double check that. Your answer there is not correct. Okay, so I think you pressed something wrong on the calculator, because here when you multiply 32 by 1,8, you should have got 57,6. Okay, and then it's 57,6 that you need to add 32 to, and then you will end up with the answer that you gave me, which was 80, sorry, it should be 87,6, not 89,6.
Oh, ma'am, I just pressed something wrong. That's why I said the wrong answer.
That's
Yeah.
okay. It's not a big deal. Okay, so that should be 87,6. All right, that's fine. Not a problem at all. Okay, Asimahle, yes, you can do the last question 212. What should we write there, Asimahle?
85.1.
85,1, you say. And tell me, how did you get that answer of 85,1?
I said 212 minus 32 divide. I said divide by 1,8 and then I minus 32.
Just say that again, Asimahle.
I took 212
Yes.
divide by 1,8 minus 32.
Okay, now unfortunately you're doing it in the wrong order. Okay, and that's why you're not getting the correct answer, unfortunately. Okay, so if you look at it like this, all right, so imagine how can I explain this to you guys that I could use something that was visual. Can you imagine if you were given a present? Okay, and your present was first wrapped in green paper, and then for some reason your mom decided to put red paper on top. So the green paper is the first layer of wrapping paper, and the red paper is the second layer of wrapping paper. Now let's pretend your mom gives you this present and says to you, here you go, there's a present for you, unwrap it. Which layer of wrapping paper are you going to take off first?
The red.
The red. You're going to take off the outer layer, aren't you? And only then are you going to be able to take off the inner layer, which was green. So in other words, if we have got an input number, all right, so in this case, let me just move this up a little bit. So let's use X as our input. Okay, if X goes in and we times it by 1,8, and we end up with 1,8x. And then we take this 1,8x and we add 32, and we end up with an output. When we want to reverse this process, if we start with our output, the first thing that we have to undo is the adding of 32. So I have to first take away 32. And then only can I do the opposite of that, opposite of timesing by 1,8, which is to divide by 1,8 in order to get to my answer. All right, so I've got to undo things in the order in which they were done. All right, so that means I've got to start with 212. Let's just rub this one over here out. And I've got to take away 32 first. When I take away 32 first, I end up with 180. Then I have to take 180 and I have to divide it by 1,8. And that leaves me with 100. Okay, so yes, Nima, you were correct. All right, let's just make sure that that's correct under there. There we go. Well done, Nima. Okay, very good. Nice one. Okay, so very important to understand that when we are working backwards, we've got to undo things in the way that they were done. All right, so if we times by 2 first and then add 3, and we're undoing it, we first have to minus 3 and then divide by 2. Okay, so that's super important when it comes to you guys solving equations, which is something that you're going to be doing a lot of when you get to high school. Okay, now here's another activity. This is something that we have looked at. Oh, hang on a second. We didn't do the flow diagram. Okay, so now I'm going to ask whose hand was up next. Roddy Vulva. Oh yeah, sure. Is that you, Buhle?
Yes, ma'am, it's me. I wanted to ask for the question where 32 times 1.8 plus 30 plus 32. Ma'am, I just checked it on the computer, not on the computer, on the calculator, and it still gave me a 89.6.
Okay, maybe I made a mistake. Let me just double check. So that was when 32 went in. Okay, let me check as well. I'm also going to work that out again.
Ma'am, I also got...
Yes, no, you are right. Sorry, I've just checked. I must have done something wrong. I beg your pardon. This is a 9. You were correct the first time. Sorry, Buhle. You are indeed correct. My apologies. Thank you for pointing that out. Okay.
Yes, ma'am.
All right, lovely. So now when we went to do this flow diagram, we were supposed to write our inputs on the left-hand side. Yeah. Yes, Cynthia.
Ma'am, I have a question.
Sure.
Ma'am, in every diagram I'm gonna do like this, ma'am, is it, well, are we always gonna times by 1 times 8?
Not necessarily. It depends on the rule that they give you.
So
Okay, so it's not
1,8.
always going to be times by 1.8. That was just what we were doing in this particular question. Okay, so each rule can be different. All right, so sometimes, so you can multiply, you can divide, you can then add and subtract, and they would expect you to be able to do all of those. Okay. All right, so if they've given you the rule, they would expect you to be able to use the rule to work out the answers. All right, so here we would have had 0, 5, 20, 32, and 100 that went in. Our rule was times by 1,8, and then add 32, and then here we would have had 32, 41, 68, as Boucle said, 89,6, and then the last one, 212. Okay, did you manage with that? Was that correct? Were there any problems?
I have a question.
Sure, Rolivua, go for it.
Isn't it, 20, isn't the answer supposed to be 67? Because that's what I got when I calculated it on the paper.
Okay, let me just double check. Is that when 20 goes in, Rolivua?
Yes.
Okay, so let's just double check. I'll also have a look here. No, I'm still getting 68.
Okay.
Okay, so if you want, do you want to do it on the side here?
Okay.
All right, so let's have a look. So the first thing that we would have to do is take 20 and multiply it by 18. Okay, so we would say 8 times 0 is 0. 8 times 2 gives us 16. Then we have to put down a 0, don't we? 1 times 0 is 0. 1 times 2 is 2. Now we're going to add those two numbers together. That gives us 0, 6, 3. Okay, so now that's got to have a decimal comma in it like that. So then we have to take the number 36 and we have to add 32. All right, so if we've got 36 and we add 32 onto that, that's going to give us 8 and that's going to give us 6. Okay, so that's where the 68 came from.
Okay, thank you.
Okay, no problem, Rolivua. I do make mistakes, and that's why I really don't mind if you guys correct me or question what I've written. I like that very much. Okay, now the rule for calculating the area of a square, and this is something that we've done before as well, we've spoken about squares, is multiply the length of the side of the square by itself. Okay, so now again, there are some input and output numbers. You guys are going to fill in the missing spaces and you're going to do the flow diagram. And Kat and I are just going to keep quiet for a little bit. And again, when you finish, you're going to put done in the chat. Okay, ready, steady, go.
Ma'am?
Mm-hmm.
Ma'am, I don't quite understand on what to do. I was probably not here when this lesson happened.
Okay, so what you've got to do, remember we're working out the area of a square, right? So if I just, hang on, sorry guys, if I just jut off to the side over here, all right? If I draw you a square, all right, and I say to you, okay, that's a square very badly drawn by me, and the lengths of the sides are all 5. And now I say to you, calculate the area of the square. How are you going to calculate the area of the square, Boucher?
Yeah.
How are you going to calculate the flat area of the square?
Ma'am, it's probably going to be maybe 5 times 5.
It is, okay, because remember to calculate the area of a square, we say side times side, don't we?
Yes.
Absolutely. So then we would end up with 25. Okay, so you took the side and you multiplied it by itself. Okay, so that's what you have to do here as well. When you go from input to output, you have to multiply the number that is given to you by itself. If you go from output back to input, that's what I wanted you to think about, because I don't know if you were here when we did that, but we've done a course on squares and cubes and number patterns and that kind of thing. So I thought that this would just sort of be an extension of that. Does that make it a little bit easier now?
Yes, ma'am.
Oh, okay, just give it a try.
Okay.
Ma'am,
Yes, my girl.
I am using my mom's phone because my phone
Okay, what's your name?
switched off, so I don't really know what we're doing. So
I beg your pardon?
it's Lesigo.
Lesigo, okay. Oh, Lesigo. Okay. Do you not know what to do for this question?
I don't understand, ma'am.
Okay, all right. So you have been given a rule for calculating the area of a square. So they're telling you how to calculate what goes into this box over here. All right. The rule is multiply the length of a side by itself. So if the length of the side of a square is 4, and we have to multiply 4 by itself to get the area, what would the area of the square be? Does that make sense to you now?
Yes, ma'am, thank you.
Okay. Oh, good. All right. So let's see here. So Bulela's done, Koliswa's done, David's done, Bulela, who else here? Luam, Buhle, Sion, Tolana. Okay. Well, that's really good, guys. Well done. Michelle's done. Alden is done. Manda's done. Watibang not done. Amila, Tinji almost. Eli done. Nima almost done. Tianwich almost done. Okay. Babalo done.
Ma'am,
Yes, Supreme.
ma'am, I'm not sure about my answer for number 4, ma'am.
Okay, well, tell me, what did you get for the first one, Supreme? What did you get the area of the square to be?
Yo, ma'am. 256, ma'am.
No, I'm afraid not. Okay.
I thought so, ma'am.
Okay, Supreme, don't worry about it. We all make mistakes. You can see I make mistakes when I work here as well. So don't stress about that. You're going to see now exactly how we're going to do this. Tolana, your hand was up first. So I'm going to ask you, what did you get the area of the square to be if the length of a side was 4?
I got 16.
You got 16. Well done. That's great. And tell us, how did you get the answer 16?
I said 4 multiplied by 4.
Absolutely. So you're taking the number and you're multiplying it by itself.
Yes,
Perfect.
by the number of sides.
Absolutely, by the length of the side. So one side times the other side. Very good. Well done. Luan, what did you get when the length of a side of a square was 6? What was the area?
Ma'am.
Ma'am, I got 36.
That's lovely. Well done. Sounded like 2 different people were talking there.
Bonolo was somewhere there as well.
Oh, okay. All right. That's fine. Let's have a look. Who's next? Buhle, you next.
Ma'am, for numbers, it is 8.
It's 8. Good. Well done. That's very nice. Patson, you're going to do the next one.
Ma'am, for this one, it's 100.
Lovely, Patson. Very, very nice. Good job. All right. And then the next person is Rolly Bua. Hold on, it's Rolly Bua.
The answer is 12.
The answer is 12. Absolutely. Okay, now.
Hello, ma'am. Hello.
Yes, Xoliswa?
Yes. Oh, ma'am, the problem is, hi, ma'am, how are you, ma'am?
I'm fine, thank you, and you?
I'm good, ma'am. The thing is, ma'am, I've had my hand up for like 10 minutes now, ma'am. I've been wanting to answer the previous questions, ma'am.
Oh, I'm so sorry. You see, what I do is I start from the top because that's the person who put their hand up first, and then I work my way down towards the bottom. So I'm just having a look at the queue of names here, and I can see that you were, in fact, next. I just hadn't got to you yet. All right. So I tell you what, since you are next, why don't you tell me how to fill in the flow diagram?
Ma'am, for the flow diagram, ma'am, we're going to be using square roots, ma'am.
Okay. So what should
we're gonna do for? So, ma'am, for the first one, ma'am, we're gonna say the square root of 4, which gives us 16, ma'am.
So there would be 4 there, and there would be 16 over here. Is that correct?
Yes, ma'am.
Lovely. Good job. Okay. Do you want to do the next one?
No, ma'am, it's fine, ma'am.
Okay. All right. All right, Xoliswa.
Thank you, ma'am.
It's a pleasure. Okay. Anzani, you are next.
Ma'am, it's going to be 6 and the output is 36.
Lovely. Very well said. Thank you so much. That's perfect. Okay, the next person is Sihle.
Hello, ma'am. Ma'am?
Yes, Sihle?
It will be 8 and 64.
Lovely. Well done, Sihle. That's perfect. Kwanda, you are next.
Ma'am, is it 10?
Absolutely. And what comes out?
100.
Lovely. Very nice. Well done, Kwanda. Letabo, you're doing the last one.
Ma'am, input is 12.
That's correct.
144.
That's lovely. Well done. That's excellent. Okay, now, Luam, I'm going to ask you a question. When I work from input to output with this particular question, what operation am I using to go from input to output? What's the operation?
Ma'am, can you repeat that again because I didn't hear?
With pleasure. So what I'm asking you is we're starting with our input and we're producing an output, all right? So if we start with 4, our output is 16, or if we start with 6, our output is 36. So I'm asking you, what operation are we using that turns 4 into 16 and 6 into 36 and 8 into 64? What operation is it?
Sorry, ma'am, we're using multiplication.
Okay, we're using multiplication, fair enough, but it's a special kind of multiplication. Do you know what it's called?
I'm not sure, ma'am.
Okay, that's fine. I'm glad that you said that. Thank you very much for just being honest. I'm going to ask Motibang because his hand is up next. Motibang, what special kind of multiplication am I using to go from input to output?
I don't know, ma'am, but to me, it's like, I think you are using geometric. I don't know.
It's not geometric, unfortunately, but I'm going to go to the next person and see if they can tell me. It's fine. David,
Okay,
your
ma'am.
hand is up next. David, what special kind of multiplying am I using here? It's got a name. Do you know what it's called?
Can I answer, ma'am?
All right, Supreme.
Ma'am, are you square rooting, ma'am?
I'm not square rooting.
Lee,
Okay.
I think Bulela in the chat has it.
Oh, let's have a look. Oh, I didn't see that. There we go. Okay, everybody, if you have a look, Bulela had the right answer. Okay, it's called squaring. Okay, Bulela, quite right. Well, the only thing that you did wrong there, Bulela, is that you just didn't spell it correctly, but that's really not a big deal. Okay, so it's called squaring. Yes.
Ma'am, is there a difference between square rooting and squaring, ma'am?
Absolutely, Supreme. Absolutely, there's a big difference, and that's why I decided to stop here and point this out to you guys, okay? Because the language that we use is also really, really important. So if you think about it, Supreme, your name is Supreme, right? So I can't come along and call you Kat or Lee or Nima or Lutle because your name is Supreme, isn't it? Okay, so we have to call things by their correct name. So when we take a number in maths, any number, doesn't matter what the number is, okay? It could be 4, it could be 5, it could be 6, it could even be a negative number. It could be an integer like -1 or -10. When we take one of these numbers and we square it, all right, when we square it, it means that we are multiplying it by itself. So that's why I was saying it's a special kind of multiplication. So we multiply the number by itself. So that is called to square or squaring. Okay. When I go back in the opposite direction, that is when I am doing a square root. So a square and a square root are opposites. Okay, these two are opposites. Okay, so it's like saying, if I say the daytime is nighttime, am I right? I'm not, I'm using the opposite, aren't I? Okay, so it's the same thing in maths. I've got to give it the correct name for what it is. And squaring and square rooting are opposite operations. Okay, so when you take a square root, you take a number like 144 and you split it in such a way that the outcome, when it's multiplied by itself, gives you that number again. Okay, so I would say the square root of 144 is 12. Or if I wanted to work out the square root of 100, I would get 10. Okay, so it's going back in the other direction. It's starting with the answer and working back to the question. Okay, so it's starting with output and working back to input. All right, so when I go that's right, the square root of 144 is 12. Right, I'm going to even write that down for you. Okay, the square root of 144 is 12. But what I would say is 12 squared is 144. Okay, does that make sense to everybody? Correct. 12 times 12 is 144 or 12 squared. Quite right. Okay, and the square root of 144 is 12. Lovely. That's very good, guys. Okay, nice. Well done. All right, so when we were working from input to output, we were squaring. And when we work backwards from output to input, like we did with 144 and we did with 84, when we were going back this way over here, we were taking a square root. Okay. All right, lovely. Okay, so the language that we use is also really, really important.